All right, today we're going to do something a little different. We're doing a digital unboxing of a really cool piece of tech, one that works quietly behind the scenes in, well, so many places. We are talking about the water pH sensor. So here's a weird question for you. How do you ask water how it's doing? I mean, it sounds a little out there, right? But think about it. For farming, for keeping our environment safe, for all sorts of industrial stuff, knowing the chemical health of water is absolutely crucial. So, how do we get it to spill its secrets? Well, you use a translator. And in the world of water quality, this little guy is the translator. A smart sensor like this is basically our tool for having a direct conversation with the world around us, turning complex chemistry into simple data we can actually use. So here's the game plan for this deep dive. We're going to break this device down into four main parts. We'll start with its most important promise, then we'll look under the hood at its engineering, check out its physical design, and finally, we'll get into the hard data. Okay, first things first. Look, if you're going to measure something, you have to be able to trust that measurement. It's the absolute foundation of any sensor, and this one makes a very, very specific promise about that trust. And here it is, that promise boiled down to one single number, plus or minus 0.02 pH. Now that's not just good, that's a level of precision that lets you make really confident decisions, whether you're trying to grow the perfect tomato in a hydroponic farm or you're monitoring a super sensitive river ecosystem. So how does it actually deliver on that promise? Well, beyond that pinpoint accuracy, it comes pre-calibrated right out of the box. That means less fumbling around during setup and, fewer chances to mess things up. Plus, the integrated electrode design means it's basically built to be dropped into all sorts of different setups without any fuss.
Okay, so it's accurate. Awesome. But is that signal going to be stable over time and distance? For that, we've got to pop the hood and see what's going on inside that makes it so darn reliable.
A measurement is totally worthless if the signal it sends back is all noisy and weak. It's just junk data. And as you can see here, all the magic that gives you a strong, clear signal is packed right into the internal electronics.
Now, these terms might sound super technical, but stick with me. It's actually pretty cool. Think of the axial capacitance filtering like a pair of noise-canceling headphones for the signal. It just cleans out all the interference. Then that massive 100 megaohm resistor acts like a megaphone, boosting the signal's strength so it can be heard loud and clear. And all of that travels down a special, low-noise cable designed to protect it. Every single part is there for one reason, to protect that precious signal.
And what's the payoff for all that clever engineering inside? You get a clean, stable signal even if your sensor is over 20 meters away from the thing that's actually reading the data. And that, right there, is a game changer when you're setting things up out in the real world. So you've got this awesome clean signal, but what good is it if you can't even get the sensor where it needs to be? So now let's talk about the outside, the physical body and how it's been built for the real world. And wow, this slide just says it all, doesn't it? On the left, you've got your standard, kind of bulky design, and on the right, this much more refined, slimmed-down version. You can see how the top part is longer, and the whole thing is just sleeker. This isn't about looks, this is all about function. So what does that smarter shape actually get you? Well, for starters, it can now fit into much narrower pipes and ports, which is a huge deal in a lot of industries. It's just smaller, easier to handle, and, this is a big one, it sips power. That low power consumption means you can run it on batteries or solar for a really long time, which is perfect for remote monitoring. And here, you can see the nitty-gritty. That G3/4 threading, that's a super common industrial standard. It basically means it's designed to screw right into fittings that are already out there. It's all about making it easy to get this thing installed and running as fast as possible. All right, we've covered the promises. We've looked at the clever engineering, both inside and out. Now it's time for the final part of our unboxing, the proof. Let's look at the hard numbers on the spec sheet, where all the claims get put to the test. Okay, this little table really tells the story. You see the full pH range from 0 to 14. There's our accuracy number again, plus or minus 0.02. It can work in water from freezing all the way up to 60 degrees Celsius. And that last one, IP68, that's really important. It's a toughness rating. It means this device is completely sealed from dust and can be left underwater like forever. Basically, this thing is built to live 24/7 in the very environment it's measuring. It's tough. Hey, remember how we were impressed with that 20-meter signal? Well, get ready for this. If you use a different communication standard called RS-485, which is designed for long-distance data, that range explodes to 1,000 meters. Yeah, that's a full kilometer away. Just imagine what that makes possible for huge farms, long pipelines, or massive industrial sites.
So, when you step back and look at the whole package, the precision, the super stable signal, the tough as nails design, you realize you've got more than just a sensor here. You've got a smart sensor. It's a device that can reliably understand its world and then communicate that understanding over incredible distances. It's one of the key building blocks for the whole Internet of Things. And that really brings us to the big final question. With tech like this becoming so much better, so much tougher, and so much more connected,